Tina, I noticed you still didn't have a partner.
I didn't want to slow anyone down.
Well, let's try something new. This is the rover. Use it to guide you in this project and bring your math to life. All right, see you later. Hey, good clap. Hey, slow down, slow down. Tina, time to go.
Tina, can you show me?
Guys, wrapping project due tomorrow. I need you to get with your team, start plotting those lines. Tina, I noticed you still didn't have a partner.
I didn't want to slow anyone down.
Well, let's try something new. This is the rover. Use it to guide you in this project and bring your math to life. All right, see you later. Hey, good clap. Hey, slow down, slow down. Tina, time to go.
Tina, can you show me?
Are you all traveling together?
Yes, madam.
सर आपके पास टाटा एजी का ट्रैवल इंश्योरेंस नहीं है क्या? It covers medical emergency.
Madhavan, can you hear me?
Yes, Rohan. Yes. Hi.
Perfect. Hi, Revati. I hope you can hear me too.
Yes, Rohan, I can hear you.
So we shall wait for like 5 minutes and wait for more people to join, and then we'll start.
Yeah, we can do
Okay.
this. Revati, are you in Chennai?
Yes, Rohan, I am in Chennai.
Is there a cyclone today?
Yes. It's a cyclone yesterday, not today.
Oh, is it? Okay. I hope these
Yeah.
are all fine.
Yes,
Yeah.
all good.
Hey guys, rapping project due tomorrow. I need you to get with your team, start plotting those lines. Tina, I noticed you still didn't have a partner.
I didn't want to slow anyone down.
Well, let's try something new. This is the rover. Use it to guide you in this project and bring your math to life. All right. See you later. Hey, good class. Hey, slow down. Tina, time to go.
Revati, can I start now?
Uh, Madhavan, I think you can start.
Yes, we can. Okay. All right. Okay, guys. So let me just for the record, we are having a webinar today on coupled differential equations, Euler's method, calculus, and functions in exam mode using TI Nspire calculator. My name is Madhavan Ramanujam. I work as a product representative for Mumbai Numerical Analytics. Today, so I would like to introduce you to Mr. Rohan Hemanth. I'm sure you might have seen his previous meetings or webinars too. Some of you may have. He has experience of close to a decade, and currently he's working as a teacher for Oberoi International. So he'll be taking you through the session. So feel free to ask any questions, or if you have any, apart from the topic, also if you have any questions, feel free to ask. If you need any help, I'll be hosting the event, so I'll be glad to help you out, and you guys can coordinate with me as well. Okay. All right, Rohan, over to you. Thank you. Thank you so much.
Thank you, Madhavan. Good afternoon to all of you. I know it's a Saturday afternoon, and we would rather be sleeping rather than getting this done. But I'm so happy that you guys have all joined in. It just shows that how passionate we are with what we do, as well as our students. I know this is just 1 hour session, but I'll try my best to cover what all is important in the exam mode. With respect to calculus, of course, my focus will be mostly on calculus. I hope you guys have all received some of the questions that I will be discussing in the session. If there are any questions that you would also want me to solve, that you would want me to solve using TI, I'm open for it. You can definitely share that question, and I'll definitely solve that right here if I have some time. So I'm going to share my screen. Okay, can you all see my screen? Is my screen visible?
Yes, Rohan, yes, we can see your screen.
Perfect. Okay. So I've already shared this worksheet. Revati, I hope everyone have got the same worksheet.
Yes, we have emailed them to their
Perfect.
email IDs, whatever they have registered with us.
Perfect. Great. Okay. So I picked up all the questions from the paper 2 especially. It's a mixture of both SL as well as HL. All these questions, how can we solve it using TI, is something that I will discuss today. That's one. Second thing, of course, this is a skill that we have to, I have been teaching my students that, look at the marks, and that's how much of time that you should be spending on that particular question. Sometimes 2-mark question, they end up spending about 5-6 minutes on it, where they're just expected to use GDC and just give out an answer. So this is where we can guide our students that to use the GDC more smartly. Not only that, even if it's a 6-7 marks question, maybe they've solved it and they want to verify the answer. Again, they can use this method to verify their answer, probably if they have a time at the end. So I'll start with the first question here. They've asked us to differentiate. They've asked us to differentiate this function between -1 and 1. And of course, they want us to find the value for it. That is one. And after that, they want us to find the coordinates of the point of the graph for the same function between -1 and 1, where the gradient of the tangent of the curve is equal to 0. See, again, this is just 3 marks. We should not be spending a lot of time on it. So how would we do this in our GDC? I will show you certain ways where there might be sub questions where you might have to also plot the graph. Let's say you would have to plot the graph. You have to sketch the graph between the domain of -1 to 1. So when you have sub questions like that, when can you get everything in one shot? Because again, time is the big constraint here. So how do you get everything in one shot is something that I will show you right now. So let's define this function in the GDC. Now, how do I define it? I hope you guys all have your GDC. By the way, it's my mistake. I will be using TI Nspire CX2. Whatever I'm going to do it with my software, that is the CAS Teacher Premium software. I'm sure I hope all of you are using the same software. I've done it with this calculator, and I put it on the exam mode and it works fine. Can I just show you how to put it in exam mode so that you guys are all on the same page and also how to exit from the exam mode. Just one quick, steps on the guide how to put this on the exam mode. This is now turned off. The calculator is off. Now, before turning on, what we need to do is we need to press the tab button. There's a tab button, and then simultaneously you need to press the on button. So tab, I'm pressing the tab button. I'm pressing and holding it, and then turn on the calculator. So when you turn on the calculator, it's already in the press to test mode. Let's say the calculator is in the press to test mode. I'm sorry, it's already in the press to test mode. I want to remove this from the press to test mode. Sometimes students will come and complain that the battery is draining or remove it from the test mode. When it is in the test mode, you can see that the light is actually blinking. So it means it is in the test mode. Now, how do I remove this from the test mode using the calculator? I mean, using the software. I'm going to connect the calculator with this cable. This cable is something that comes with the calculator, and the USB is connected to the laptop. I've connected the GDC to my laptop, and that GDC now will be visible right here. It will load up and you'll be able to see it. Okay, I didn't connect the USB. I just connected the USB. Yeah. Yes. So now you can see the calculator that I've connected here. This is in the test mode. I want to remove this from the test mode. The process of removing this from the test mode is in this Teacher Premium software, you have an option here with the GDC symbol. If you click on that, there is an option to exit from the press to test mode. And when you click on that and click on exit press to test mode, it will automatically exit the calculator, and you see it will restart. The calculator will restart again. It means it is removing the calculator from the exam mode. So now this calculator is not in exam mode. It is not in calculate. This calculator is not in exam mode. Now, how do I put this back on exam mode? Without any cable, that small cable used to come in where one calculator will be in exam mode, and then you connect this and then you transfer the exam mode to this, right? Because the settings has to be the same. So to make it more easier, the fastest way to do this is you turn off the calculator. I'm going to turn off the calculator. The calculator is off now. Now, while turning it on, I need to press the tab button and then turn on. And when you do that, you'll see this symbol where you'll get the codes like that. So that is the code for putting it on the exam mode. So the exam mode for IB exams are 4 zeros, the first 4 zeros, and then 1790. So the numbers are like the 000 and 4 zeros, and then 1790. So once you put that code, it automatically puts this calculator on the exam mode, which is required for an IB exam. What all should be enabled and disabled, it will automatically be done. So click on the next button and then click on start. If you want, you can just go through the options, which all will be restricted, which is as what is recommended by the IB, and click on start. Automatically, the calculator will now restart, which means the calculator now is going on the exam mode. So there you go. So if once you click on OK, done. Your calculator is on exam mode, and you'll be able to see the light blinking again, which means it is on exam mode. If there's any doubts, please let me know. You're free to please stop me at any point and ask me questions, or even put up a questions in the chat window. So once this calculator on exam mode, what all options are available, I will only be using that. I'll probably also show you something extra, which as a teacher, we can definitely use. This is for our teaching purpose only. But what can students use for the exams is what I'll be mostly showing here. Now, I'm going to start from the questions. So that's the first question. Sine inverse of x plus 2 into root of 1 minus x squared. I'm going to define this function. Again, I'm doing this because I'm showing that, let's say there are not just two sections, there are subsections. Maybe the student is required to graph it, or maybe the student has to integrate it after some time. Maybe it's connected to area questions or a volume question, something like that. So let's say there are multiple questions like that. So the student might take up a lot of time to defining that function at every point. So to save that time, he can predefine that function. And I would always recommend using the document pages, because we can save all the work that we have done. So an advantage of using a document, and also you can use multiple pages there. Now this is the calculator page. On the calculator page, I'm going to define a function. Of course, you can do it on the graph window as well. I'm going to define this on the calculator page. Now to define a function, there are many ways. The most easiest way is what I found out was using this. You need to just click on menu and the first option, actions, and then define. First action. So now you can define whatever you want there for the functions. Now the function, I'm going to give a name to it. F of x is equal to, this is sine inverse of x plus 2 into root of 1 minus x squared. And the calculator is in the radian mode. Of course, if you want to change that in the degree mode, in the new calculator, all you have to do is just click on that option and it will directly convert into degree mode or radian mode. In the old calculator, it's a little different. I'll show it to you how to change the angle settings as well. Now I'm going to define the function. The trigonometric functions are right here. This is like a bubble buttons. You have all the fly buttons, different names for it. So you'll probably see the sine inverse there, sine inverse of x plus 2 into 1 root of. So the root symbol is right there. Control root of 1 minus x squared. Okay. So once I do that, so there you go. The function is defined now. The function is defined. Now, of course, the differentiation is something that cannot be done. We can do it with the teacher software, but students have to, of course, differentiate it manually. But the part B where they have to find the gradient of the tangent, it's basically the derivative of that function that is done in part A. They have to find the value at the value of x at minus 1. So the way they can do that is menu options and calculus, derivative at a point. So derivative at a point, the derivative variable is x and the point is minus 1. Of course, we want the first derivative. Now, what is a function? F of x, right? So I don't need to write the whole function. I will just call that function there, f of x, and that gives me the value here, f of x as minus 1. Is it minus 1 there? Yes. Did I miss out anything? Okay, sorry, I read the question wrong. They're asking where the gradient of the tangent is 0. See, I'm sorry, I read the question wrong. So what we're supposed to do is, we were supposed to find the derivative of the function where it is 0. We have to find the x value where the derivative between minus 1 and 1 is 0. So what we're supposed to do is, of course, the function is not defined between minus 1 there. So what we need to do is, we need to insert a numerical solve. We need to insert a numerical solve. To insert a numerical solve, click on algebra and then numerical solve. That function f of x, right? The derivative of function, sorry. So the derivative of function is menu, calculus, and we will, to insert derivative option, you have either one, or you can do it that way, or there is another option here, right next to the number 9 button, where you have all the options to define the derivative, the sigma notations and all those things. So you have the first derivative here. So click on that. So d by dx of that function f of x, that function f of x is equal to, they've told that the gradient of the tangent at this curve is 0. So therefore, we will equate this to 0, comma, the value what we want is here x, right? We want the variable that is defined here is x. Now, between what points? Between -1 and 1. The condition is between -1 and 1. To do that, we need to define a condition here. To define a condition to this equal symbol, right? If to use these options, that is inequality symbols, there is also a conditional operator there. To use that option, you need to click on control and that equal to symbol, and then you have the condition operator. So in that, we will specify that x value should be between -1 and 1. So -1, x is greater than -1 and less than or equal to 1, because it's 1 and -1 both are included. So there you go. And hence we get the answer as 0.5. Okay. So hence we found the coordinate of x as 0.5. So there's absolutely no need to do differentiate it and equate it to 0, solve it algebraically. There's absolutely no need to do this. They can directly use the numerical solve. And this 0.5, okay, what is the y coordinate? Well, just f of 0.5. So the x coordinate is 0.5 and the y coordinate is 2.26. And that's how they can find the coordinate of the graph where the tangent is, the gradient of the tangent is 0. So this step will be more than enough. Any questions, please let me know. Revati or Madhavan, I'm not able to see the questions. The chat window, if there's any questions, please stop me, okay?
Actually, Moinuddin has raised his hand, but he has not yet asked.
Okay. All right, so I'll move on to the next question then. So I hope it's clear now how you can use numerical solve. So numerical solve is an option where you can put in your probability functions there, derivative functions, integral functions. You can do a lot of options there. And but the catch is that it can only give you one solution. So if you have multiple functions, then you should know where is your solution existing. Is it between like this? If we specify a domain, then we can find each individual answers one by one. Otherwise, that is one drawback that you can only find one solution at a time. If you want multiple solutions at a time, then of course you can use graph. Now, let's say I've defined this function. I would want to graph this function. Maybe I would want to integrate it, find an area or something like that, or sketch this graph. You will probably insert the graph window and enter the graph and then copy down to the notebook. Now, a faster way to do that is you can just right click on it. Now, using the calculator, how do we do that? To access that, control and menu. If you click on control and menu here, that option will take you to graph. So automatically you'll be able to graph this. You'll be automatically able to graph this same graph between -1 to 1. So that is one thing that you can do everything at one shot. So there's no need to rewrite the function because it might be a huge expression. The student might at least miss out like 1 or 2 minutes on that. So things like that can be done in a shortcut method.
Rohan, there's a question in the chat box from Mr. Subramanian Manigandan. Madhavan, can you unmute him, please?
Yes, one second.
Revati, I think Moinuddin is asking for questions. He could not find it, it seems.
Yeah, I'm sending him.
Sure.
One second, I'm unmuting him. One second.
I think I understood what his question is. I think he's asking me to just repeat that numerical solve method again. No need to waste time. It's fine. It's okay. So, sir, I'll show you the. Yeah.
Sorry, I have actually unmuted. Mr. Manikandan, you can ask if you want to ask.
Yes, exactly.
Okay, so you want me to just show you the steps again, how to solve the numerical?
Yes,
perfect. Yeah, no problem. It's okay. So see, I've already predefined that function. I've predefined this function f of x. It's already saved. Now, the derivative of that function is equal to 0. Now, for what values of x? Now, I'm solving that using the numerical solve. So that option is available on menu, algebra, numerical solve. Probably in the normal calculator, you'll be able to see just the numerical solve because you'll not have all these options because this is a premium software, of course. But yes. So algebra, first option, numerical solve, the first option. Once you choose that option, we have to mention that it's the first derivative of that function. The first derivative of that function. So to access that first derivative operator, it is right here next to the number 9, that button. It has all these options. So first derivative, second derivative, or nth derivative, or even integral for that matter. All these operators it has. So I'm selecting the first derivative because it's talking about the tangent. So d by dx of that function f of x, which I've already predefined, is equal to 0, comma x, because I need to define what that variable is. Which variable am I trying to find? And then I need to put the condition. Even if I don't put the condition here, I might get the solution. But then sometimes, like I said, the solutions can be existing at -3, -2. The numerical solve will give you a solution, the first solution, which is closest to 0. Maybe this solution might be the value which is closest to 0. But if there is any other solution which is closest to 0, then you might want to be specific about what domain are you looking at. So hence, we will mention the domain by using that condition operator. But to access that, you need to use control and that equal to button, and you have that condition operator, and we'll specify the domain of x. So -1. Again, an inequality operator is here. X is between -1 and 1. So, Mr. Subramaniam, I hope it's clear. Same way, shall we try the second question? They're given as a function. Let P be the point where x equal to 2. We have to find the gradient of the curve at the point P. Same way, we need to define the function. They're asking now to find the gradient of the curve. It's just 2-mark question, so we don't have to spend so much of time differentiating and so on. Maybe how do we do this? We can again predefine the function again. Let's define the function again. I can see a lot of questions there. Okay, so this will work only if we know the domains. Yes, correct. Yes, exactly. Usually in the question, they will specify the domain, right? Even if they don't specify it, when you graph the function, you'll notice that these are your solutions. This is where my solutions are. So you can also probably make it specific that give me a solution between 2 to 3, 3 to 4, so on. Yes. Okay, moving on to the second question. Again, I'll predefine this function now. F of x as ln of 3x minus 1. So again, to define, I've used 2 questions of same time so that maybe some of you might want me to do it again. So hence, I've taken up a similar question. So menu actions define f of x equal to ln of 3x minus 1. Ln of 3x minus 1, done. It will be saved. Now what we want? Derivative at a point. We want the gradient of the curve at the point P, and the point P is x equal to 2. What is the y value? Well, what is f of 2? That is the y value. Now what is the derivative at 2? For that, all you have to do is again, menu, calculus, derivative at a point. So the variable is x, the value of x is 2. First derivative is what we want. Click on OK. Now what is the function? F of x. That's it. And that's your answer. So 0.6. There is an exclamation mark, meaning that there are multiple solutions. But the solution close to x equal to 2 is 0.6. Okay, I'm going to minimize this. Yeah. So 0.6 is the answer for it. Of course, this will be the gradient of the tangent, and then they want you to the normal, find the coordinates of r. Well, the normal to the, you have to find the equation of the normal, and then where it touches the x-axis, so on. I'm not going to go into that, right? It's the same method after that. So I thought I'll also add in an application of integration in probability density function, where we'll have to find mean, median, and so on, right? Now I've taken up a question for mean is just the integral area question, right? So since I'll cover that in some of the question, I didn't want to do that. I thought I'll do it for the median. Now, median is basically the midpoint. We are talking about the area under the graph to be the half of it, not just one, half of it. Now, what is the point where the area becomes half? Well, we have to integrate this function between 200 and the other point. such a way that the area under that is off. Now, how do we enter this in the graph? Probably this is a question where students, of course, have to do it manually and then find the value of m, because this might be a 7 or 8 mark question. But then how do you verify the answer? How do you verify that whether you got the answer right or wrong? To do that, again, we'll have to predefine the function. Even if you don't define it, it's absolutely fine. How do you do this without defining? Menu, algebra, numerical solve, and we will enter the integral, right? So menu, calculus, we will apply integral there. The integral, the lower bound is 200, because if you see there, it is x is greater than or equal to 200. So 200 is the lower bound. Upper bound, I'll put some m as the variable, and we'll have to define the function. Now, the function is in the form of rational. So you can either write it just automatically or you can use this operation again, the button next to the 9, which has this rational function or rational number way of writing it. So that makes things a little more easier. So 2.5 into 200 to the power of 2.5 whole divided by x to the power of 3.5. X to the power of 3.5 dx. Okay, this is done. This area is equal to 0.5, right? Because it's a median. Okay, but what is that value of m that gives me 0.5? So hence, I'll have to define the variable m, comma n. Enter, that's it. So 264 is the answer. 264 is the answer for that. All right, I'm moving on to the next question.
Rohan, there's a question from Mr. Arvind. You can just have a look. He's asking, can you solve a question which have multiple solution by using nsolve?
Multiple solutions, yes, of course. Like I said, you need to specify the domains. Yes, of course, I'll do one of those. I think I do have one of those questions, Arvind. I will definitely solve that, yes. Okay, this is the function here, e to the power of x sine 2x plus 10. I don't know if I've sent you this question. I just found this out. Probably I thought I'll also cover this while I'm doing calculus, because I found this to be interesting. Now, I'm going to predefine this function again. Define again, menu, action, define. There's other way to define the function also. Probably I can show you that as well. You might also have a doubt, what if I have multiple functions? Of course, I'll show you how to define multiple functions too on the calculator. The function here is e to the power of x sine 2x plus 10. So e to the power of 2x, e to the power of 2x, sorry, e to the power of x sine 2x plus 1. Now, if you are familiar with sine function, how to type in, it's okay, because those are inbuilt function. The moment you type in, it comes in. Otherwise, you can just directly use this trigonometric fly button. I will just type in sine, okay, sine of 2x plus 10. Maybe you want to sketch this graph, right? Maybe here I think I'll show you, Arvind, how do you find the solution? What if you have multiple points, right? I'll show you. So let's say you want to graph this function between 0 to 4. Of course, you can define the condition here, or we can also define that in the graph window. I will graph this and show it to you. Now, like I showed you, how to graph this without rewriting this function. Well, if that multiple windows is very confusing for you, absolutely fine. You can insert another document by clicking on doc, insert a graph window. We will insert a graph window. No need to enter the whole function again. We'll just type in f of x because it's already saved. So it automatically plots that function, whatever we have predefined. Now we need to define the windows. So the windows is between 0 to 4, right? 0 to 4. So x value is 0 and the y value is 4. Sorry, minimum value of x is 4 and the maximum value of x is 0 and 4. Sorry. Now we'll fit this graph within that 0 to 4. So menu, windows, and fit it. See, if it's toggling between this is very difficult, you can just use this keyword also. If you just type in the A, it'll automatically fit the graph according to the domain, whatever we have entered. So this is the graph between 0 to 4. Now we want to find the maximum point M, minimum point, and the x-intercept, the A coordinate. Of course, all the operations are under menu. In the calculator page, menu. For calculus, algebra, finance, anything, it's under menu. Now graphical, to analyze the graph, finding the zeros, maximum point, minimum point, anything, again, it's under menu. So analyze maximum point, will define lower bound and upper bound. So that is the first coordinate. We can always move this. If it's too much, you cannot see the points. If it's all occurring at one place, and then if you want to find the coordinate of 0, menu, analyze 0, and then of course minimum point. There you go. So those are our 3 points, maximum, minimum, and the x-intercept. That's the coordinates for P, Q, and A. Now we need to integrate it and explain why it is not. Well, again, see, this is again just a 3-mark question. You see, the function is such a big function. Would you expect a student to spend a lot of time applying integration with paths here? No, not required. You will directly use the calculator with the coordinates of x and m and n, x coordinates, whatever we have found. Now to do that, you can go back to the place where you have defined the function, menu, calculus, and integral. It's between, so the x coordinate here is 1.02. That's my the highest value, and the lowest value is 2.59. 1.02 and 2.59. Okay, so this is my n, and that's the q and p basically, right? Because that's what they're told. P is the value for m, and the q value is for the n. 2.59. Now we will call the function whichever we have defined earlier. So f of x dx. That's it. That gives us the answer. Of course, the answer will, this doesn't represent the area because of course some of them is below the x-axis will be negative, and that is the reason the students will enter. Now let's say between Arvind asked the question of what if there are 2 solutions here. Let's say you want to find 2 points of x-intercept. It's just not A, there's one more point of x-intercept here. Now, how do you find 2 x-intercept using the numerical solve? We plotted the function, or we know that it is between, there are 2 solutions to it. Usually trigonometric functions will have multiple solutions because it might be repeated or periodic or so on, right? Now, how do you find those multiple functions, multiple solutions? So menu, algebra, numerical solve, f of x, right? That's the function equals to 0, comma x. I'll define the function that I'll define the condition. Okay, x is let's say, what is the graph here? Okay, x is greater than 2.5 maybe, or x is greater than 2.5. So that's a solution. Now similarly, I would want a solution which is greater than 2.5. Maybe there's one more x-intercept greater than 2.5. So that way you can keep changing, toggling between the domain of x to find multiple solutions. Here x is greater than or less than 2.5, right? So there you go. We get 2 solutions for the function at multiple domains. I hope I've answered the question. So same way, this also, just like how I solved the median function, you can also write this function as an integral function, the numerical solve, equate it to 1/2, predefine the variable as a. That's it, and put the condition of a between those 2 points, or that's it. That's your answer, or whatever answer of a you get, answer of a should be between those 2 things. So it is the same process that we will do for this question as well. Any doubts? Okay, no doubts on this. Moving on to the second question. I'm going to rush through a little bit because I need to talk about coupled differential equation as well. So here, f of x is given as this function, x into x minus 5 the whole square. Find the area, predefine the function, or write it integrate it between 0 to 5, and that's your answer. Volume, pi into f of x whole square, again, write in the same function, so on. I'm not doing A and B. I want to do the part C. The part C is where whatever answer you got for the area from part A is something that we will be using again here. They've told us that for this graph, that's a quadratic function, this area is equal to the area whatever we found here, but we need to find the value of A. So same thing, numerical solve, menu algebra, numerical solve. We will insert the integral. The integral is between 0 to A. The function is, 0 to A. The function is x into x minus A dx is equal to whatever area. Let's say it's 52. I think I remember seeing the answer as 52. I'm not sure if it's 52.1 or something like that. Anyway, comma A. There you go. And that will be our answer. Of course, it's not 52. I'm guessing it's something else. We can verify that. We can get that answer from by integrating this region between 0 to 6. Something like that is the answer. Okay, but the process is the same thing. The process is actually the same way. Sure. I think I just added 2-3 questions. All these things are there. All these questions are already there, I'm guessing. 1 or 2 questions are not there. I'll definitely share it again with Ms. Revati. Maybe she can mail it to you again. This is a question where I have taken from the specimen paper. I wanted to share this because I did come across this where students were struggling to solve this by converting this into a simultaneous equation. I wanted to mention this because, well, once you convert this into a logarithmic function like what the mark scheme says, it is in the specimen paper, you can go and check. When you're entering this in your simultaneous equation solver, that is using menu, algebra, and solve system of linear equations, probably here the variable is 3 variables, right? So when you're writing these equations, just make sure that you have to write x into y into, please do not write it as x. And even if you had paid attention here, I wrote it as x into, because we have to make sure that calculator that, that variable, that's a variable and that's a constant and so on, or that is a coefficient and so on. Okay. And we cannot write log k in the function. So that's why we can predefine this function as z, and then using the z, we can find the value of k. I just wanted to add that question so that I did, one of the students was asking me, and I thought I'll also address that today in our webinar. I'm moving on to the last question, where it is coupled differential equation. I'll talk about this also. I'll come back to this. Coupled differential equation is something that many of you have asked at Oxford. I'll solve this, then I'll come back to the question number 5 and 4. Okay, so this is a second order differential equation. We have to convert this second order differential equation into a coupled differential equation, and then of course using Euler's method, we have to estimate the value at x equal to 2. The initial values are given as 1, -2 for t equals to 0. I have already written this second order differential equation as a coupled differential equation. We will be defining dx by dt as y. So therefore d squared x by dt squared becomes dy by dt. So hence this differential equation becomes dy by dt is equal to 3x minus 2y. So the first differential equation is dx by dt is equal to y. The second differential equation is 3x minus 2y. Now, if you remember the Euler's method formula is here t is the independent variable. So t is equal to t, the previous t value plus the step length, whereas the x and y value is x, the previous x value plus h into the derivative of x, and y value will be the previous y value plus h into derivative of y. And this is what I will be entering in the calculator. I will take my time here. I will not rush in. If you have any doubts, please feel free to ask. So here, I have to predefine these two functions. The reason why I'm telling that we need to predefine it, see, sometimes you can also write this same formula in the list and spreadsheet. But what happens is sometimes when you're typing in, something might go wrong. Maybe you might lose out a value there or lose out a variable there. To go back and check, it's a little tedious is what I have experienced. So if you predefine it, once you predefine it, you can play around. You can change the H value and then see how the graph changes. Is it becoming more and more accurate, more and more closer to the solution? Is all something that we can play around once we define the function here. So I'm going to define the function same way, menu define. There's another way. I'll also show you another way, and it's up to you which one you want to choose. Now, how do you define another way? So first we'll give it a name, f of x comma y, because this function has two variables, not one variable, no, two variables. Even here also it has one variable, but it's okay. I'm going to use two variables. It does not matter. If I'm not using the function, it does not matter. If I'm not using the variable later, it does not matter. Now to define this function, there's a define operator here. The button that we were using to enter the first derivative, second derivative and all. To access that, click on control and the define operator. Now we will write the expression. That's it. That defines the function f of, that is dx by dt. Now I'll define dy by dt as g of x comma y. G of x comma y, control and the button again. This function is 3x minus 2y. 3x minus 2y. So it is done, it is saved. So I can keep calling it multiple times. I will also predefine the h value, the step length value is 0.2. So h is 0.2. Now using this, I will write down the formula for Euler's method in the list and spreadsheet. I will insert a list and spreadsheet, doc, insert, list and spreadsheet. If you want to go back to the different tabs, all you need to do is just click on this. If you think that is very difficult, then you can also use this operation by clicking on control and the up button. You'll be able to see your different tabs here, and then clicking on the tab which you want to navigate to. So I'll define the columns, right? So t is the first variable, x and y. Y in this case is my dx by dt. So initial value is given as 0. When t is 0, x is 1, and dx by dt, which is y, is minus 2. So my next value of t is nothing but the previous value of t plus the step length. So just like how we write a formula in Excel spreadsheet, click on equal to sign, A1, or you can just click on that also, A1y, A column, first row, plus h. Now we need to fill this formula till we get the value of 2, right? Because they want us to find the x value at 2. So to fill that formula, click on menu, data, and fill. Menu, data, fill. And drag it down till the column where you want it. So that's your x, what t equals to 2. Now we'll similarly define the formula for x equal to the previous value of x, that is b1 plus, this is the Euler's formula, h into f of, because f is dx by dt, f of x comma y. So x in this column is b1, comma, y in this column is c1. Enter. F of b1 c1. Same, we need to maintain that same order. Again, menu, data, fill, till 2. Similarly, for y, this is equal to the previous value of y, that is c1 plus h into dy by dt. I defined it as g of x comma y. So g of b1 comma c1, x comma y, right? b1 comma c1. Enter. Menu, data, fill, and then fill it till. I hope I'm clear. So that's how we define the formula, and then we fill this formula for the rest of the code. Now, the next part of the question is they want us to sketch the graph x against t between 0 to 3. Now, what you do, we have already written the formula till 2. We'll just copy this formula till 3, right? So menu, data, fill it till t value equals to 3. Similarly, this value is also, we'll fill it, menu, data, fill it till 3. Of course, we'll not get it until we also do the same thing for y, menu, data, fill. With the software, actually, I'm doing it how we would do it in the calculator. In the software, you can do everything in one shot. Software is a little more easier. In the GDC, you have to do it individually for every columns. So that's your value for x, and that's the value for t. Now we'll plot this in the GDC. How do we plot this? There is another window called as data statistics. Data statistics is basically for scatter plot, to do any kind of statistical calculations, or also regression, modeling of function, or plotting the data points, so on. So to access that, you need to click on Doc, Insert, Data and Statistics. You'll see the points. All the points that we have found in the list and spreadsheet is randomly distributed here. So we'll add the x variable here. X variable is t, and the y variable is x. And you'll see the points of x versus t. Maybe this might be a question on Prey and Predator model or a couple differential equations. Probably they want you to see the phase portrait, things like that. Maybe this might be a question. I think there's an eigenvalue questions. Yes, of course. They want us to find the eigenvalues and eigenvectors for this. And then based on that, they want us to see if it's a stable condition or an unstable condition. So I will show you how do you find an eigenvalues quickly using the GDC as well. No need to solve the whole polynomial and all. How do you solve this using GDC quickly? That also I'll probably show it to you. I can see some questions. Slope field. Well, I can show you how to sketch the slope field, but on exam mode, the slope field will be disabled. That's why I'm not showing it to you. I can definitely show it to you because I put the calculator on the exam mode, and if you insert a graph and if you go to differential equation, you see it will be graded out. I will insert a graph, and I can show you that when I'm inserting a graph which is like a differential equation, you'll probably see that it is graded out. So that option will not be applicable on exam mode. But then if you're asking how to plot a slope field on a GDC, maybe for your teaching purposes and all, yes, of course, I can show you that to you. So I will insert a graph. So once you insert a graph, menu, and what kind of graph do you want? Do you want a function, relation? See, on the exam mode, equation templates, differential equations will be out of bound for the students to use. All the other things will be, they can use. Of course, most of the things it's not applicable. Now, let's say you want to plot a differential equation. Maybe you want to plot a slope field. So the slope field is, let's say, 3x minus 2y. Okay, 3x minus 2y. Here, y1, because I'm defining it as y there, I will also write this as y1. Now, I'll have to give the initial points. Maybe I'll give it as, or a point that function is passing through. Okay, so there you go. That's a one particular solution that it draws the graph and tells you that this is a graph because you're giving a particular solution. But if you don't give a particular solution, of course, these are the slope field that you can use for your teaching in the classes. I hope I've answered the doubts. No more questions, right? Yes, welcome. Okay, so that's how you can actually draw a slope field using the graph window. So the next question that I've taken up, how much time do I have? 10 minutes. Okay, it is the same process. This is from the paper 3 that I've taken from 2021. This is about, again, a prey and predator model. We have to, again, predefine this function in the calculator, and then same way what I've done. They have given us the initial values of mackerel and the shark population, and using the step length of 0.1, you will have to estimate the population after 1 year, and then draw the trajectory, how it looks, so on. The same process.
Rohan,
Yes,
Mark has asked a question, I think. Please repeat the slope field.
Yes, of course. Could you repeat slope field? Absolutely, sure. Start from a new window. See, this is a bad habit that I always start from a new window, because sometimes when you define a function, if you open a new window again, and if you're working on it, and if you predefine the function, without even unknowingly, you might be getting solutions wrong. So that is why I have a habit of creating a new document, so that whatever we have stored or whatever we have defined is all cleared out. Okay, you don't want to do that, is absolutely fine. If you want to, another way that you can do it is click on doc, and then you can insert a new problem. Okay, insert a new problem. So once you insert a new problem, you can define everything again from the scratch. So I'll add a graph window. See, 2.1. So the first question was 1.1. It's like a sub question, right? Sketching, finding calculations, finding the list and spreadsheet, and so on. Now 2.1 is the next problem. Now I want to plot a differential equation, because that's how I would get a slope field. Now to insert a slope field, we need to go to graph, entry, edit, and choose the 8th option, differential equation. Again, this is not on exam mode. I'm just keeping you guys informed. Differential equation. Type in any equation you want. 3x minus 2. I'm using that because I did define that function earlier. And I'm writing this as y. Put in any point the function is going through. Even if you don't put it, it's absolutely fine. It will just tell you the slope field of the possible curves, right? But with a particular point, it will tell you, okay, this is one of the curves that it's passing through these slope fields. Now to do that, let's say you've done this and you want to go back and edit it. Click on tab. So you need to click on tab, and then click on up, right? Go up, go to the previous function, and then you mention the point the graph is passing through. Probably it's passing through 1, 2. And that's the shape of the graph. If you think the slope field is very far off, maybe this is something that you're going to use it for your teaching in classes. If you think that why Euler's method is not accurate, because the slope field is out very far apart. Now, how do you make it very accurate? Well, get the slope field more closer, right? Make the step length more lesser. To do that, of course, you can go click on this, and then you can click on this and probably change the iteration steps here, change the resolution. You can just play around with this. That's what I would recommend. Nothing will happen, don't worry. Just play around with the values, and you'll probably see that, okay, I'll increase the field resolution to 100. What will happen? So there you go. I get the slope field more closer to it. So that's how you can get to see the shape of the graph more clearly, or the slope field more clearly. Madhavan, any more questions?
Yogita asked a question, I think. Did you address that? How to interpret face portrait?
Oh yeah, done. Yes. Thank you, Yogita. Yes.
And
okay.
Yeah.
Okay. So what I've done, what I'll do is now to find the eigenvalues. Of course, you know the condition, right? If the eigenvalues, I'll start only with the real condition. If those two real values are positive, it's unstable. If both are negative, it's stable. If one is positive, one is negative, it is saddle point. That's how we differentiate the condition, right? Or the eigenvalues, or the condition of the face portrait, right? Now, how do we get the eigenvalues? Now, once we write this as a matrix form, the quotient of x is 0, the quotient of x is 1, dx by dt, and dy by dt is 3x minus 2y. So I'm writing the coefficient of x as 3, the coefficient of y as minus 2. I've written it already so that things will be a little more faster. I've written the characteristic equation here. So 0 minus lambda into minus 2 minus lambda minus 3. So there's absolutely no need to sit and solve this. They can directly use graphical method. They can put this in the graph window. I will insert a graph window here. Lambda is x basically. So minus x into minus 2 minus x minus 3. That's it. So you see one of the solution is 1. The other solution is minus 3. Well, I'm telling it with naked eyes because it's very clearly visible. But of course, you can find it more accurately by clicking on menu, analyze, 0. So one of the solution is 3 minus 3. The other one is 1. Since one is positive and the other one is negative, we can call it as a saddle point. We can call this point as a saddle point. Of course, based on that, we will the equilibrium point is a saddle point. And based on that, we will draw the phase portrait once we find the eigenvector. Once these eigenvalues are found, put in back in the matrix and find the respective eigenvectors, and then sketch the phase portrait. Yeah, perfect. Yogita, I hope I answered your question. Do you think I should leave this last 5 minutes for any questions, or should I solve one more? I mean, I have more questions.
Yeah, there is a question from Ravikant Patula.
Okay.
Could you repeat the slope field?
Yeah, I did.
You did, right? Okay.
Yes,
okay.
I did.
It's an old question, I guess. Okay, sorry, never mind.
Okay, perfect. Now, I did add a question on kinematics also here. I did add this Markov chain question is because same way I wanted to show you how to find eigenvalues and matrix and all. I think I've pretty much answered it. Now, this is a question on kinematics. Once you plot this function, same way how we did it earlier, you have to find the point where determine the coordinates of A and B. That's fine. Hence, write down the maximum speed of the body. Well, we'll take the absolute magnitude. So B might be the speed of it. Then once the body comes to rest at time t is equal to t1. Well, you will find the time t1, and then you'll find the distance. The distance traveled will be integral of this function. Again, I've showed you how to integrate the function. This function between the coordinates 0 to t1, whatever t1 coordinate that we find here. And then acceleration is nothing but the same function, whatever you have defined, differentiate, use that menu operation, right? Menu, calculus, derivative at that point, whatever point you find, and that will be your acceleration. So there you go. With the calculator, we'll be able to solve all these questions. There's absolutely no need to waste time on sitting and differentiating because it's not needed. The 6 marks might be divided into 2 marks. So it's absolutely not needed for them to sit and show us all the steps of differentiation or integration for that matter. Again, find the distance between 0 to 30 seconds. Well, 0 to 30 seconds is right here. So probably they will write it as an absolute function. Maybe this I will show you how to use the absolute function to find the distance. Displacement is fine. It is just a normal integral. But this distance is a little different, right? So doc, insert, I will insert a calculator. Menu, calculus, integral between 0 to 30. This function. See, if I had defined this function in the beginning, it would have been more than enough for me to answer all this question. There is no need for me to define that function again and again. So I could have saved so much of time, right? I hope you guys are able to see that the advantage of defining it initially. Now, this distance is an absolute function. So I'll insert the absolute operator. Again, it's right here. It's right here, right? So we'll insert this absolute function. Now that will be 2 times of, again, it's in the radian mode, so no need to worry. 2 times sine of t by 10 or x by 10, it's absolutely fine. So even if you use t by 10, it's absolutely fine. You have to just write it as t there. So t by 10 plus pi by 5. So pi is, you can get that from here. So pi divided by 5 times cosecant of, so cosecant is here, cosecant of t by 30 plus pi by 4. So t by 30 plus pi divided by 4 dt. So that will tell me the total distance traveled between 0 to 30. Again, this is just a 3-mark question. There's absolutely no need to do the integration. We are seeing that are they writing the integral properly in the correct notation, and are they giving the right answer? That's it. Okay, I think that must be end of the session, Madhavan.
Yes, we are done. Unless anyone wants to, we're done with the session. And unless
Yeah,
anyone wants-
Madhavan, you could unmute all the participants. So if they have any questions, they can.
Absolutely, yes.
Yes, just give me 1 second. I'm doing that.
So participants can ask questions. So you all have unmuted.
You have been unmuted, guys. You can ask.
Thank you, Ms. Monica. Thank you.
Yeah. Excuse me, can you hear me? Good morning.
Yes.
Good afternoon.
Yes.
This
Good
is Markandan. This is Markandan from. Okay, quickly. I don't want to waste your time. How to draw phase portrait in this calculator? Could you show, please?
How to? I'm sorry, I didn't get it.
Draw the phase portrait.
Oh, all right. So phase portrait. Okay. So actually, what happens is phase portrait is a condition that based on the eigenvalues and eigenvectors, what the condition is, then they have to draw the phase portrait. Now, another way to draw the phase portrait is, in fact, I did the one question where I did solve this. Yeah.
Yes.
This might be a slope field. So based on the x and y values, let's say x represents one kind of a species and y represents another kind of species, and the time t represents the time. Now you found the population values of population of these two animals, and you would want to see how the slope field looks like. So maybe you can put x and y variable here. So you have defined x here. Maybe I'll put y in this place, and I'll put x in this place. And then you'll be able to see the slope field of this. When we are talking with respect to a pre and predator model. I hope I'm making sense.
Good. I'm happy.
Yeah.
I'm going to teach in next week. That's why. Thank you.
Perfect. Or also using the eigenvalues and eigenvector condition, you know how the slope field, the phase portrait will look based on the direction, whether it's coming in or going out or so on. I would recommend just have a look once at the notes too. Yeah.
Yeah, definitely. Thank you.
Yeah. Welcome. Any more questions? Thank you all. Any question? Yes. Hi.
We can use sequence and custom way of sketching the calculus equations. Is it also we can use that app during the exam mode also? Can we do that?
I think so. I'm not sure about it. I've not tried it actually, Ms. Yogita.
Like
I've not tried it.
Euler's formula only. Like
Yeah.
I use Cognity, and there is a TI app how to use that. So we can see we can interpret it from that.
You can absolutely can do that. Absolutely you can predefine the function just like how you would do in a different. Yes, of course you can do that too.
But
you can do that too.
Can we do during the exam mode also?
Absolutely. It is there. So if you click on menu and this calculator is on exam mode, I'm just checking this. It is there. The sequence option is enabled, so they can use it.
All right. So we can write the sequence.
Absolutely.
And then we can have the sketch of the graph after using the custom, right?
Absolutely. Yes.
All right. But I'm still not clear with the face portrait, I saw there is one question on the population between, I think rabbit population and all. I forgot.
Yeah,
the-
that's a paper. Yeah, okay, okay.
And in that we need to find out the population, making equation t equals to 0. What should be the population when x is greater than 2000, something like that. I really don't understand that question.
Oh, that is actually one. See, there are multiple ways of solving a couple differential equation. One is Euler's method. The other one using the initial condition. If you remember, you need to make an equation in terms of x and y using the eigenvalues and eigenvector, right?
Right.
So using that, you substitute x as 2000 and find the t value. Substitute another animal's population as that and find the t value. So you have to take each of those functions separately. I'll just write down here with my on my OneNote.
Oh, all right. I remember. Right. They have the general solution. Right. Right.
Correct. Exactly.
Right.
So like this, right?
E to the power of lambda pt something.
Lambda
like
1t.
Right,
yes.
Right. Correct. Right. Oh, got it. I recall. Thank you. Yes.
Welcome. Okay.
Thank you, sir. Thanks a lot. It was a wonderful.
Welcome. Thank you.
Okay. Please share the class link for today's one. You mean the recording?
I think the recording. I think I saw someone was asking for recording. Yes.
Okay. This is Mark, right? Mark has asked. Okay.
Yes, Mark under. Yes.
Okay, sir. Okay, I'll share that. Yes.
Thank you.
All right. Thank you very much. Thank you.
Okay, guys. Thank you so much for attending. Thank you, Rohan.
Yes,
welcome.
Mr. Hemanth.
Amazing
Have
session.
a nice weekend.
Thank you so much,
Sure.
Mr. Hemanth.
Welcome. Thank you. Nice talking to you all. Bye.
Yeah.
Bye. Thank you. Bye-bye.
Yes, Manikandan, I'll send the recording. Yes, I'll send the recording. Thank you all for attending the session. And if you have any, I have put my number on the chat. If anybody wants to ask any questions after the session, feel free to drop me a text. I'll share the link. Yes.
Thank you.
All right. Thank you, guys. Have a nice day. I'm ending the session. Thanks for enjoy your weekend. Take care. Bye, Revati.
Bye.
Bye, guys.
Bye,
Bye,
Mr.
everyone.
Thank you.
Thank you. Bye.